Greetings and salutations. Today we have a lesson on coterminal angles. We're going to be talking about what they are and then how to find them. And we're going to be doing this both in radians and degrees. So that is a heads up of what we are doing. So first of all, what is a coterminal angle? And basically what happens is, let's pretend I have an angle on the coordinate plane. On the coordinate plane, the first side is always right here. That will never change. And the second one, let's just say I want to put it right here. Boom. And that is my angle. And if I was to ask you, what angle is that? Well, then you don't actually know. And there's two reasons you don't know. First of all, you can tell it's less than 90, but you can't tell how much less than 90. Right? Actually, no. You can't tell that it's less than 90, and that's kind of the point that I'm going to go for here. It looks less than 90, but it only looks that way. For all you know, this is like, I don't know, 80 degrees. But when it comes to angles on the coordinate plane, they don't have to be between 0 and 360. What if I was to tell you that this angle actually went and opened all the way around and then came and ended up right there? That wouldn't be 80 degrees anymore. It would be a full 360 and then 80 more. But wait, what if it wasn't that? What if instead I started at this beginning point and then went backwards a full circle and then backwards to find this one over there? And it's like, you can't tell. Without any more information, you can't really tell. That's why usually people will label it, like if you have an angle like that, they'll just put the little thing right there to show that they are talking about the number less than 90. But otherwise, you can't technically tell. It might be going full circle and then more. Maybe it's going 7 circles and then going there. Or it's going backwards some amount of circles and then ending there. Those are coterminal angles. If you like if you like English, co means with and term means end. So they end with each other. They end at the same place. An example of that that's pretty easy is like 90 degrees and negative 270 degrees. These are considered coterminal because a 90-degree angle would look like this, right? But at the same time, if you went negative 90, negative 180, negative 270, you would end up with this angle right here. And they look exactly the same, right? If I was to do them next to each other, here's 90, and then here's negative 270. And they look exactly the same. They are coterminal angles. So that is what a coterminal angle is. It doesn't have to be in degrees. I'm just doing it because degrees tend to make more sense to people since you learn about them before radians. I could say this is pi over 2, and I could say that this is negative 3 pi over 2, and they are the exact same. They are coterminal angles. Keep in mind that means there's technically an infinite amount of coterminal angles. This was me doing the 90 and negative 270, but I could have done a full circle first and then gone the 270. So there are an infinite amount of both positive if you go forward a circle, or negative if you go backwards a circle. How to find them. In degrees, it's pretty easy. Just to show you why it's easy, is I'm just going to pick 120 degrees. So this is 120 degrees. A lot of times, at least when I ask questions, I ask for one positive and one negative coterminal angle. And all you have to think about is, like, if I start with 120, how much more do you need to do in order to go another full circle? So like you've already gone 120, and how much more do you need to show you need to go one circle? For that, all you need is how many degrees are in a circle. And that is 360. So you would go 360 degrees plus 120. And that is equal to 480 degrees. So 480 degrees is a coterminal angle. But what if I wanted to do 2 circles? Go 1 circle, go 2 circles, and then another. Well, all I would have to do is tack on another 360. in which case you would get 840, I think, probably, my instincts. In which case this is another coterminal angle. And the whole thing here is that you can just keep adding 360, because 360 is one circle. It doesn't actually move the angle. If you go a full circle, nothing changed. Full circle, nothing changed. Or backwards full circle, nothing changes. So you can actually keep subtracting 360. If I took 120 and subtracted 360, that would be negative 240, I believe. And that would be a negative coterminal angle. And you could keep subtracting 360. 360 minus that would be negative 600, I believe. And you can keep adding or subtracting 360 as many times as you want. So plus or minus 360 degrees, as many as you want or needed. I'm just going to put as needed. Because, more than likely if you're doing this, it's because you need to. I don't know how many of you would want to do this, but keep adding or subtracting 360 until you get a positive one, until you get a negative one, or both, just depending on what your question is or what you're looking for in math. Radians is a little different because remember, degrees, there's 360 degrees in a circle, and the whole point is that you're going a full circle. So, how many radians are in a full circle? The answer is 2 pi. So, instead of doing the plus or minus 360 for degrees, you're going to have to do a plus or minus 2 pi. So, if I have 3 pi over 4 and want to find a coterminal angle, I could add or subtract 2 pi to get my final, coterminal angles. You just have to be careful, because this is a little bit more complicated than degrees. Because degrees, these are just whole numbers. Adding whole numbers is easier. With fractions, you cannot add these right now. 3 pi over 4 plus 2 pi, they don't have a common denominator. Right now, this one's over 1. So you have to get a common denominator. In this case, you would multiply it by 4 over 4. So you'd have 3 pi over 4 plus or minus 8 pi over 4. And then you can do this pretty easy peasy. 3 plus 8 is 11, so 11 pi over 4 is a coterminal angle. If I wanted to add it again, I would just keep adding this 8. I could add 8 again to make 19 pi over 4. Those would be coterminal. I could be subtracting 8. 3 minus 8 is negative 5, so negative 5 pi over 4. I could subtract 8 again to get negative 13 pi over 4. As many times as needed, you can add or subtract 8 pi over 4. Because that's, what it is once converted. The reason I keep saying as many times as needed is because sometimes I'll give a question that's like negative 24 pi. Oh, I screwed myself over. 23 pi over 4. In which case, if I want to add or subtract the 2 pi, I'm not going to subtract because it's already really negative. I would want to add 2 pi, which once again is over 1. Once again, you'd have to make this a 4, multiply it by 4, so you actually get 8. So you get 8 pi over 4. So then when you add 8 to negative 23, that's negative 15 pi over 4. But it's still negative, and I want a positive one, so I would have to keep adding 8. Did I do my math right there? I think I did. Minus 8 again, or plus 8 again would be 7 pi over 4, which, is still negative. So I would add 8 pi again, and I would finally get pi over 4. So I actually had to add like 3 times in order to get finally a positive number. So like I said, it's as many times as needed. And there you go. That is doing the radians, degrees, coterminal angles. Hopefully not too bad for you. Degrees, add, subtract 360. Radians, add, subtract 2 pi. But make sure that you are getting a common denominator. Have a good one.